This is chapter 2 in Bio 181. We'll start with key concepts. Atoms are made of positively charged protons, negatively charged electrons, and neutral neutrons. So these are the three main subatomic particles that make up atoms. The simplest atom is called hydrogen, and hydrogen has one proton and one electron. The positive charge, the negative charge cancel each other out, so this is neutral. If we add another proton, we have the next atom on the periodic table, which is called helium. Now, helium, in addition to having the two protons, also has two neutrons. It also has two electrons that are orbiting it. These two electrons have a charge each of -1, so they cancel out the +1 for the protons, so the overall charge is neutral. Okay, I'm going to erase this. Go to the next slide. Okay, so on the left, you can see that we have, this is helium. This model here, this drawing is called a Bohr model, which you will be required to interpret and also to generate. In the center, you can see there's the nucleus with the protons and neutrons, and around them orbit the electrons. Over here, this is from the periodic table on the right. At the top, this is the atomic number. This is the number of protons. So there's two positively charged protons here. The chemical symbol of the element is helium, so that's shown in the middle. And then the atomic mass is the average for all helium atoms on the planet. Now, some of these have an extra neutron or two, so this average is not a whole number. In general, the atomic mass is going to be equal to the number of protons plus the number of neutrons. So, for example, if I said the atomic mass was 4, and I told you it was helium, then you would know that because you have 4 total for the atomic mass, you subtract off the number of protons, which is always going to be 2, and that gives you the number of neutrons, which is 2. Okay, I'm going to erase this. Go to the next slide. All right. So neutral atoms, as I said, have the same number of electrons and protons. Ions have an unequal number. So if we look at helium here, it would have 2 protons, 2 neutrons, and 2 electrons, right, that are orbiting it. So if helium happened to lose an electron, it would just be pulled off, say, by some other very, very strong atom that has a positive charge. Then you would be left with an atom that had 2 positively charged protons in the center, 2 neutral neutrons, and just 1 negatively charged electron around it. So you have a +2 in the center here and a -1 out here. So the whole net charge on this +2 - 1 would be +1. So that would be helium ion, which would do He+. Okay, which is actually quite rare. Next, so I'm going to go to the next slide after I erase this slide. Okay, so this is looking at a Bohr model, and you say, well, what are we looking at? Well, if I told you that this is neutral, then that means that the number of electrons is going to be equal to the number of protons. So you can count up the number of electrons. We've got 1, 2, 3, 4, 5, 6. Now, since I told you it's neutral, that means the number of electrons is 6, and that means the number of protons is 6. So if you go to the periodic table, you can look for the atom that has the atomic number of 6 and you would find out that it is carbon. All right, I'm going to erase this. Go to the next slide. Okay, so these are some Bohr models, just a few examples. So the first one up here, we went over, that's hydrogen. If I was to draw that, that'd be a +1 proton in the center and 1 electron out here. So that is hydrogen. And again, the chemical symbol is H. Now, if we were to add up to find the mass of this, that would be just +1. There's only 1 proton in the center. So that's the mass again is the number of protons plus the number of neutrons. So in this case, it's equal to 1 plus 0, which is equal to 1. Okay. Let's go down here to lithium. So for lithium, we have 3 electrons on the outside. So we're going to start with that. 1, 2. And it turns out that after the first orbital, it only can have space for 2 electrons. And after that, the electrons actually have to move out further away from the center, the nucleus, to the next orbital. So there's 2 electrons closest to the center and 1 that's out further. Now, lithium has an atomic number, let me just tell you, of 3. So that means in the center, you have 3 protons, 1, 2, 3. Now, if I tell you it has an atomic mass of, so generally the atomic mass of lithium is 7, then I would say, okay, so how many neutrons are there? Well, remember that the atomic mass is equal to the number of protons plus the number of neutrons. We know that the mass is 7. We know that the number of protons is 3 because that's the atomic number. And then we want to know the number of neutrons. So basically 7 minus 3 is equal to 4. So that's going to be the number of neutrons. So if I was to draw this, I could put 4 neutrons right in the center, 1, 2, 3, and 4. And that's my Bohr model. So the first orbital fills up with 2 electrons. The second orbital fills up with 8 electrons. And then the next, it has to go out to the next orbital, and that will also fill with 8 electrons. And that's really what we're going to be concerned with in this course. So, oh yes, and then this concept, I'm just going to mention isotopes. So isotopes have a different number of neutrons. So helium is the most common. Let's actually do, I'm going to do hydrogen. So hydrogen generally has 1 proton and 1 electron. And so that's going to be just H. But sometimes on the planet, you will find hydrogen atoms that have 1 proton and they have a number, 1 neutron. They still have 1 electron in general. This is an isotope of hydrogen that actually has the atomic mass of 2 because it has 1 proton and 1 neutron. Whereas over here, the first one had an atomic mass of 1. So this is an isotope of hydrogen that has an extra neutron. Okay, and then the last thing for, oops, let me go back. Okay, the last thing for this video, I'm trying to erase this. Okay, the last thing for this video is that, back. All right. I want you to know that the most common atoms are hydrogen, carbon, oxygen, and nitrogen. So a way to remember that is CHON, that's carbon, hydrogen, oxygen, and nitrogen. So I want you to know that in every living organism, O, X, Y, D, E, N, these four elements make up 96% of the mass. Okay, so 96%, which is crazy to me. So you got all these different atoms, but 96% are these four. And then if we go to the next two, which I'd like you to also know, the next two are sodium, Na, and chloride. Okay, so if you put these together, that's actually salt. So I want you to know that 96% is CHON, and then the next two on the list are sodium and chloride. All right, and that is it for this video.